All right, this whole chapter is on triangles. Just triangles. We should know what triangles are. Yep, 3 sides, 3 angles. We've talked about those. They do equal 180. We haven't gotten to that yet, but that will be 100% fact. We're going to start off with acute angles. Well, an acute, so we could talk about triangles in terms of their angles and their sides, and we're going to combine them into one long statement. So we're going to start off by classifying triangles based upon the angles. Now, if you ever find yourself with a triangle that has 3 acute angles, now remember, an angle that's acute is one that's less than 90 degrees. We've covered that before. Right is 90 degrees. Obtuse is bigger than 90 degrees. So all 3 of these angles are acute angles. Well, if you have 3 acute angles, the name of that triangle is an acute triangle. You have nothing but acute angles, so you call it acute triangle. It's a nice little acute little triangle.
What if you only have like 2 acute angles?
Well, if you only have 2 acute angles, that means you either have one obtuse one or one right one. It's the only one that works out. So in this case, we have one obtuse angle. This is going to blow your mind. Anyone want to guess what you call it if you have one obtuse angle? It's an obtuse triangle. Right? Wow, indeed. They really stretch the imagination of math terms here. What do you think they call it if they have one right angle? It's a right triangle. Now, I'm going to do something else here. Instead of writing the word triangle, I'm actually going to put the symbol triangle. It saves some space having to write triangle over. Kind of like with angles, rather than having to write angle every single time, we could just draw a picture of the angle. Same thing here. If I mean triangle, we can just put a triangle there. Now, the next one is 3 congruent angles. So all 3 of those angles are in fact congruent. And it turns out if all of them are congruent, they actually are always going to be 60 degrees. It's the only way that a triangle can have 3 congruent angles. We don't need to memorize that right now, but that's going to come up in a lesson. So why not introduce it now? Okay, so I have 3 angles that are congruent. Now, here's where it's not as nice of naming, because we had an acute triangle, an obtuse triangle, a right triangle. This is called equiangular. It makes sense mathematically wise because they're saying you have equal angles. It is called equiangular. An equiangular triangle. Equiangular. Does anyone remember a term that sounds like equa, but had to do with a triangle? Equilateral. That deals with sides that are congruent. So this is based upon the same idea. If we have 3 sides that are congruent, it's equilateral. If we have 3 angles that are congruent, it is equiangular. All right, so what we're going to do is we're going to go ahead and we're going to classify each triangle based upon their angles. Now, all you need to do, now you can, if you want to very lightly draw on there, but basically what we're trying to do is we have triangle CDE. Your job is to figure out what triangle they're talking about. So when they say CDE, you have to just trace it in your mind or actually with your pencil. CDE is that triangle there. It's that triangle that has those 3 vertices in it. Now, like I said, if you're doing it with your pencil, just do it lightly because you're going to have to erase it because you know you're going to have to talk about more triangles. Well, do you see how this has a right angle here? So we're going to call this a right triangle. A right triangle. Now, if I had my pencil, I'd erase it, and I'd go to the next one. The next one says BCE. Your job is just to find B, trace it down to E, and then go back up to C. So they tell you the order to do it, just like with an angle, how they tell you what angle to do. They're telling you what triangle to look at. That's a triangle BEC. I'm sorry, BCE. I kind of went the wrong direction when I drew it, but that's still BCE. Does that angle look obtuse, acute, or right? It looks obtuse, so it's going to be an obtuse triangle. Obtuse triangle. Do the rest of those. Once again, you can either do in your mind, like visually check what triangle they're talking about, or actually just shade it in a little bit. Yeah, I'll be right over. Finish these off. So we have ABE. If I highlight ABE, let's go A, B, E looks like it's down here. That looks like an equiangular triangle. Equiangular triangle. BDE, let's get that highlighted. B, D, E. Well, if we got a 90 degree in here, this must have been an obtuse angle because it's bigger than 90 degrees. So that should be an obtuse triangle. And our final one is Sphi. Sphi is CFE. CFE. All those angles are less than 90 degrees, so that would be an acute triangle. It's a cute little triangle. Any questions on any of those? All right, so the only hard part is just memorizing those words, right? Know all those words. I said that's the hardest part. The hardest part about this is memorizing the words. Okay, now we can name it by angles, or we can describe it based upon the side lengths. Well, we already kind of discussed if all three of our sides are congruent, we're going to call it an equilateral triangle. That is called an equilateral triangle. Now reach back in the day. Maybe this is pre-algebra. Does anyone remember what it's called if two of the sides are congruent? They failed you. It is called an isosceles triangle. It is called an isosceles triangle. Now, these aren't as nice as acute, obtuse, and right. These really are. We have to memorize these words. So isosceles. It's up there too. Oh, that's how you kind of had an idea.
I knew it was one of these.
One of them. You had a good shot at it. Then maybe we're looking forward at stuff, but does anyone know what it's called if it's no congruent sides? It is called a scalene triangle. It's called a scalene triangle. It does a little bit, right? A terrible medication. Well, hopefully you're not taking scalenes for anything. Kind of sounds like scabies or something. A disease trial is a scalene triangle. All right, some examples. These are always nice because they just have tick marks on them. We just got to look out for the tick marks. So our first one is JKM. It is not going to be isosceles. It's going to be scalene. And why it's going to be scalene is none of the side lengths are exactly the same. Here's my advice to you for scalenes. If you're unsure what it is, it's probably scalene. Because you have to be very clear that these are equal to each other, and we don't have those marks on it. So this is going to be a scalene triangle because none of the sides are congruent. Now, if you look at KLN, so if I do KLN, that one should be a little bit more obvious. What kind is KLN? Are all three sides congruent? How many sides are congruent? Two. So it's got to be an isosceles triangle because there's only two that are congruent to each other. So that's going to be an isosceles triangle. Anyone want to take a guess at what the last one is? And it's going to be, right? Because we got to roll through all of them. But let's take a peek at it. JKN. Do we see one tick mark on all three of the sides? Yeah. That means all of them are congruent, so that must be an equilateral triangle. Now, here's the thing about triangles. I said we can name it by its angles, we can name it by its sides, but traditionally we put both of those names together into one long name. So we know exactly what we're looking for. I want to know angles, and I need to know sides when I'm drawing or looking for a particular triangle. So what's going to more show up on like quizzes and tests are going to be like 9, 10, 11. They say classify each triangle by its angles and its sides. So we have to do both. So the first thing we're going to do is we're going to name this triangle by its angle. What kind of triangle is this if it's based upon just the angles?
Right.
It's a right triangle, but it's also isosceles, so we call it a right isosceles triangle. Right because it has a right angle. Isosceles because it has two congruent sides. And triangle because it's a triangle. Our next one, 114, is that acute, right? Or it is obtuse. So it's definitely obtuse. Now, here's going to be a problem with the problem like number 10. Does it kind of look like these two sides are the same length? It looks like it. Did I mark them as being congruent? So it's going to be scalene. That is correct, because I did not put marks on it. There's no directions that say put marks on it. So we have to put obtuse scalene triangle, because we don't know. There weren't marks put on it, so we have to say it's a scalene triangle. Do you see all these sevens? That means all the sides are the same, right? You could, if you want to, you don't need to, but you could put tick marks on it to show yourself that that is equiangular and equilateral. It is equiangular. And before you flip the page, stay here, even if you have it down. Equiangular and equilateral. I think some of us probably heard of the term equilateral before. Maybe we didn't remember what it's for, but I think most of us heard equilateral. How many of you heard equiangular? Probably not very often. And you want to know why? Because when something's equiangular, it is automatically equilateral. So moving forward, if I ask you to name it based upon the angles and the sides, and you put equilateral, you have it correct still. You don't have to name both. You can just put equilateral if you want to. I'm definitely not going to take off points if you put equiangular and equilateral. I'm just saying, for most mathematicians, it's just an equilateral triangle. We don't call it equiangular and equilateral because every equiangular triangle is equilateral, so we just call it equilateral because it's the more traditional one to say. We clear on that? Just like you can use the word triangle or you can use the symbol triangle as well. All right, last couple ones. Obtuse, right, or acute? Yes, it's one of those. Which one is it for number 12? It's acute. Do we have any sides that are the same length?
No.
No, so that's acute. Scalene. And it is a triangle. Our next one definitely has a right angle on it. It has that little square there, so we know it's right. Is it isosceles, scalene, or equilateral? It's got to be scalene because all three are different lengths, so it's right, scalene, but it's still a triangle. 97 degrees. Does that mean it's obtuse or acute?
Obtuse.
It means it's obtuse because it's bigger than 90 degrees, so we know it's obtuse.
Nope.
It is the common, heard in all my classes. A lot of people said it's scalene, but look at those two sizes. We have 5 and 5, right? That means it's isosceles. Hey, what I'm going to do in the future is typically if I see numbers on it, I'll put tick marks to show myself because we're going to have big pictures like this. Also, let's just pretend if you ever have a problem that looks like this, where you have tick marks and a 5, I'd immediately put the 5 there. So I know the lengths are there. All right, so that's obtuse isosceles triangle. And then we'll get to the most difficult version of these, where you have to do some work before you start marking things down. We have 2 important things in our directions if we read them. We have PR bisects SRT, and the other one I'd highlight is U is the midpoint of RT. Classify each triangle by its angle and sides. Now, if I give you those 2 important facts, that means you need to put more marks on this drawing. You have to know what bisect means, and you have to know what midpoint means. Hey, Miss Bacon. Yep. Okay, yep. All right, so when you read the word bisect angle, if you remember from your pink sheets, bisecting an angle means it creates 2 congruent angles. It cuts an angle in half. So what you need to do is you need to locate that PR and that SRT. Let me just highlight it. So this is my PR. And this angle here is my SRT. Can we all find that angle and that line on our sheet? You don't necessarily have to highlight it, or you can just color it in. Just make sure you can erase it, because we're going to draw triangles on there. So this angle here is being bisected. That means if half of it's 30, the other one is 30 degrees as well. So bisect means that both of these angles must be the same measure. So this is where I would put marks on here. Now let me get rid of these drawing real quick. We'd put a mark here and put that this is also 30 degrees. So because this line bisects it, we have a 30 and a 30, and both of those angles are in fact congruent to each other. The other thing says that PR, U is a midpoint. So locate U and tell yourself that's a midpoint. Well, a midpoint cuts a segment in half. So that means either side of a midpoint is the same length. So I'd go ahead and I'd put a tick mark right here. So you are in charge of making these tick marks. If you don't do that, you're going to get several of these questions wrong, even though you know what the triangles are. We have to know basic geometry to keep working in this class. So the basic geometry is angle bisector cuts in half, 2 congruent. Midpoint creates congruent segments. All right, the first one they mention is UQR. So let's look at UQR. Where are you? Here it is. UQR. It's definitely obtuse because we have 120 degrees here. So it is an obtuse. And if you look at these 2 tick marks on here, it must be isosceles. So it is an obtuse. Isosceles. We have an obtuse isosceles triangle. I should have did this so I could go backwards. Let's try to erase that. Come on, purple line. You can go bye-bye. All right, we'll do one more together. We have RST. RST, if I highlighted this with my pencil, starts here. R, S, and T would be this triangle here. What's the measure of each of those angles?
60.
It's each 60, so that means it's equiangular, right? So it's equiangular, which means it has to be equilateral, but let's check to make sure it is equilateral. SR is 16. S to T is 8 plus 8, which is 16. T to R is 8 plus 8, which is 16. So I could have just put equilateral on there too. I'm going to put equiangular, equilateral, but you could have just put equilateral if you wanted to. This one, a lot of times people put both of them down because they saw the equiangular first, but it also is equilateral. Let's do the rest of them. Be careful on these because tick marks mean they're the same measures. So you actually have a lot of measures of 8 up there. SRQ. So if I find SRQ, we should notice that we have a right angle and all 3 sides are different. So it should be right scalene triangle. So that should be a right scalene triangle. Remember, if you have anything wrong, either ask a question or change it on your sheet because these are your notes. All right, PRT. Let's find PRT. Be careful on PRT. We should get the obtuse portion right because it's a wide open angle. So we should have obtuse. I don't know why I put a dot in there. But what we might have messed up on is that this is actually an obtuse isosceles triangle. And it's isosceles because this is 16 and these are both 8. Remember how we put that tick mark on that midpoint? So if one of them's 8, then the other one must be 8 as well, which makes this total length 16. So that's a 16, 16 that is isosceles. So let's go ahead and erase. So we got an obtuse, isosceles triangle. All right, then we have TQU. TQU, TQU. Do you see how we have the 2 tick marks? That means this is 8. This is 8. That's 8. This is equilateral and equiangular. So you could just put, I'm just going to go ahead and I'm just going to put equilateral because I said that's fine. We can just write equilateral. But it's okay if you put equiangular, equilateral. It's good practice. Do you understand why that one's equilateral? So we have to be a little bit ambitious, and when I put marks on things, maybe put those numbers on there. So maybe if you're doing this problem, equilateral, don't erase. So maybe we should have put an 8 on there as well to see all of them are 8. All right, our final one is PQT. I'm going to do that in red because I can't erase that purple for some reason. We should have realized that scaling, but there's something else you needed to realize. You see this 90 degrees here? This is a vertical angle. This is a vertical angle, so this should have been 90 degrees as well. Angles that are directly across from each other are equal to each other, so that's a 90 degree. This needed to be a right scalene triangle. So everything we learned about angles is still prevalent in this chapter. You still have to recognize things like linear pairs. You still have to know what midpoint means. You need to know what bisector means. You need to know what vertical angles are. So everything just comes back. You have to know how angles work in this chapter. All right, we got a couple more problems that involve algebra. The first one has, is that knocking or is that one of you guys? Okay. The first one has, okay, we have an equilateral triangle. We have an equilateral triangle where all the sides are congruent to each other. So if you want to, you can put tick marks on each one. So real quick, if AB is 49, guys, if AB is 49, how long is BC? If AB is 49, how long is BC? 49. How long is AC? So they're all equal to 49, right? So that's where we're going to steal our equation from. We're going to say they're all equal to each other. So 3x plus 1 must equal 49. We should also have 18y minus 41 equals 49. These are just two algebraic equations to find our missing variable. So I have 3x plus 1 equals 49. And the other one is 18y minus 41 equals 49. Now remember, when we're solving for these, we always do our addition and subtraction first. So I want to deal with this positive 1 because you want x all by itself. What's the opposite of adding 1? Subtracting 1. So we're going to subtract 1, and we're going to make sure we do it from both sides. So I have 49 minus 1. My 1 and negative 1 cross out, and I have 3x equals 48. Then I have 3 times x. The opposite of multiplication is division, so I'm going to divide both sides by 3. 3 over 3 is 1, so I have 1x is going to equal 16. X just equals 16. Once again, we do our adding or subtracting first, so I do the opposite of negative 41, which is a positive 41, so I'm going to add 41 to both sides. That way that negative 41 and that positive 41 cancel out. And now I'm going to be left with 18y equals 49 plus 41 is 90. Divide both sides by 18. And you're just going to have y equals 5. Now, I highly encourage you to draw pictures. I know these are all equilaterals, but I'm telling you in your homework, you're going to have isosceles triangles. You're going to have to realize which sides are equal to each other. So I'm going to take a second. I'm going to draw that picture PQR. So we have P, Q, R. It does says it's equilateral, so I can put the tick marks on all 3 of them. If it's isosceles, I will tell you which sides are congruent. Now we just take what's up here and plug it by the sides. So it says PQ equals 18x plus 1. So we're going to put an 18x plus 1 on the PQ. QR is 24x minus 17. And finally, PR is that 15x plus 10. All sides are equal, right? All sides are equal, so you can pick the equation you want. Because this must equal this. So we could do 24x minus 17 equals 15x plus 10. We could say 15x plus 10 equals 18x plus 1. We could do 18x plus 1 equals 24x minus 17. That works for an equilateral. All of them will be a good equation. Now, can we all look up here real quick? Let's play devil's advocate and pretend we're on our homework. On your homework, what I'm going to do is I'm going to tell you the length of each side, but I'll tell you which sides are congruent to each other. That makes it an isosceles triangle. If it's an isosceles triangle, you only have one equation you can do. You can put the 2 sides that are equal to each other equal to each other. That's it. So if it's an isosceles triangle, there's only one equation that works. If you're doing an equilateral triangle, it doesn't matter which equation you set up. Someone name one of those sides. Or give me the equation that's by one of those sides. Any 3. What was that? 15x plus 10. Someone give me another side. 18x plus 1. Those two have to be equal to each other because it's an equilateral triangle. So that's how I'm going to pick my equation. You just pick 2 of them and you put an equal sign between it because equilateral triangles, all 3 sides are equal. So if you picked any two sides and put an equal sign between it, you come up with the exact same answer. You can't go wrong with an equilateral triangle. All right, now I need to solve for x. Now remember, when you're solving for x, you want to put all of your x's on one side first. So I either need to subtract 15x from both sides, or I need to subtract an 18x from both sides. It doesn't matter which one you do. I'm going to go ahead and I'm going to subtract 15x from both sides, because my whole goal is I want to get rid of the 15x from this side. But what I do to one side, I have to do to the other side, so I'm going to subtract 15x from this side. My 10 carries down, so I still have 10, equals 18x minus 15x, which is 3x. That 1 carries down, and I have a plus 1. Make sure your variables line up. I saw in the test people would do like minus 15x, and they'd put the minus 15x underneath the 1. Those aren't like terms. You can only combine things that are like terms, so match up your x values. So if I'm subtracting 15x, make sure it goes below the 18x. Otherwise, you did it wrong. Now I'm going to subtract 1 from both sides, noting that I'm putting the negative 1 under the 10. So those cross out. But it goes under the 10 on the other side, so we're going to have 9 equals 3x. Divide both sides by 3. I'm going to put a little arrow here because I'm running out of room. 9 divided by 3 is 3. 3 equals x. Here's the problem. You don't get all the points for this problem. It didn't say just solve for x. It says solve for x and find the measure of each side. So that means we need to plug that 3 into each of these x values. So for example, you don't really have to. If you know what's going on, you really don't have to. But we'll go, let's find PQ. Well, on here, PQ is 18x plus 1, but we know x equals 3. So PQ is going to be 18 times 3, because once again, I took this x equals 3 and I plugged it in. So instead of 18x plus 1, I have 18 times 3 plus 1. Well, if you had your calculators like you're supposed to, what's 18 times 3 plus 1? Yikes, we have 2 people with calculators. Oof. Yep, it's going to be 55. To find QR, we have to do, well, instead of 24x minus 17, we're going to do 24 times 3 minus 17, which I'm not going to wait for just only 2 people with calculators. That should be 55. And finally, our PR should have equaled 15 times 3. 15 times 3 plus 10 would be 55 as well. These are your final answers, 55, 55, and 55. They all had to be 55. It's an equilateral triangle, so all of the sides need to be the same. So Logan, I think it was you. Do I have to plug it into all of them? You don't. You can plug it into one of them and say the rest of them must be 55 too, because it's an equilateral triangle. That doesn't work for an isosceles. An isosceles, you might find 2 of them, but you do have to plug it in for that third side. Real quick, who's got their calculator out? We had Guadalupe and Aaron. You had your calculator out, or did you? Yeah. All right, I'm going to give you guys bonus points today. You'll get an extra credit point today for doing the correct thing. Shouldn't be a bonus point, but hey, if you're the only 2 that are doing the correct thing, then you get the bonus point. All right, the last kind of one is, it's pretty much the exact same thing as the one we just did. We have STU. So I'm going to draw my triangle. So we'll have STU. However, we have to come up with the equations. They give it to us in English. They don't put it as an equation. So if you look here, it says ST is 1 less than twice x. What do you think of when I say twice x for an equation? We think 2x, right? So we know there's a 2x in there. We have 1 less than 2x. less should tell me to 2x minus 1. So we're going to go and find ST input 2x minus 1. Then it says 37 less than 5 times x. Well, if twice x is 2x, what's 5 times x? 5x. And less means subtract, right? So 37 less must mean I'm going to subtract 37. It's 37 less than 5x, so that's 5x minus 37. That's going to be for my SU. SU is 5x minus 37. All right, our very last one, we'll do that purple. It says 11 more than x. Just 11 more than x. So I'm not multiplying x by anything. What am I going to do with that 11? If it's 11 more, I add it. So we'll have 11 plus x or x plus 11. And that will go right here. And we have an equilateral triangle, so that means I can put tick marks on all 3 of these. And it is your job right now to solve for x and then give me all 3 side lengths. And when you have it, I'll check you off and then you can work on your homework. We still have like 40 minutes left in class, so we should be able to get a good jump on that homework, if not finish it.